Let's look at the capability index one more time. So first, prerequisite, the process is in control. So that is a prerequisite. And now let's suppose that we have USL and LSL, and this is the nominal value or target value, right? So here remember, LSL is lower specification limit and USL is upper specification limit. Now we have the process that is in control. So let's take case 1. Okay. Suppose if the process control limits are like that. So this is the lower control limit and that's the upper control limit. So which means when the process is operating properly, some of the parts will fall outside the allowed tolerance limits. So we cannot say that the process is capable of meeting the specification limits. So clearly, case 1, since the control limits are larger than the specification limits, even when the process is operating properly, some of the production will not meet the specification limits. Therefore, the process is not capable. So in this case, C sub pk will be less than 1 because the denominator will be larger than the numerator. Now let's look at a second case. Case 2. Okay. Let's suppose that under case 2, the control limits coincide with the specification limits. So this is the case where C sub pk will be equal to 1. That is, the numerator and the denominator are equal. Okay. Now this is also considered not capable because this is a statistical measure. So just because it is exactly meeting or exactly equal to the specifications, you cannot guarantee that there may not be any problems with the products that are produced by this process. But because the control limits do not have any cushion or safety margin. Now let's look at case 3, where the limits are, well, maybe something like that. Okay. Now, if you look at case 3 carefully, you'll see that the variance seems to be pretty small. Here, since the width of the control limits is small, C sub P is probably greater than 1 1/3, but since upper control limit is greater than upper specification limit, C sub Pk will be less than 1. Therefore, the process is not capable. Now let's look at case 4, and let's see. So case 4, since the control limits are well within the specification limits, that is C sub Pk is now going to be greater than 1 1/3, the production will almost always, there is still a chance because there is only a statistical measure that it may not meet the specification, but almost always will be within the specification limits. Therefore, the process is capable. Okay, remember, don't write is in control, because the prerequisite is the process is in control. Okay. So here in the first case, the control limits are outside, so the process is clearly not capable. Here it is barely meeting the specification. We need some margin, so we will not consider this to be capable also. Looks like the variance is capable, but it is off-center. Because it is off-center, this is coming out to be not capable. And besides, it's also falling outside the upper control limit. Now this one is the good case where everything is inside the specification limits.